Here is this week's homework for targets 5 through 7. So remember on target 5, all we are starting off with, no, this is target 5. Well, there's a typo on your copy, make that target 5. All we're starting off with is growth or decay. So when you're going from an equation, you want to focus on the base value, the b value, what's being raised to an exponent. So on number 1, the b value is 8. Since that's bigger than 1, that means this is growth. On number 2, the value being raised to the exponent is 1/2. Since that's less than 1, that is not growth, that's decay. So all you're focused on is that b value. I'm ignoring everything else in the equation. So on number 3, b is 5, which means it's growth. On number 4, b is 1/4, which means it's decay. On number 5, b is 1/2, which means it's decay. So all I'm focusing in on is that b value. I'm truly ignoring everything else. So b is 3, which means it's growth. Then moving on to target 5 from a graph, we're just looking at the graph and seeing whether it goes up or down. So going from left to right, number 7 is going up, so that would be growth. On number 8, from left to right, it's going down, so that would be decay. Number 9, from left to right, that's going down, so now it would be decay. And number 10 is increasing from left to right, so that would be growth. So target 5, you were just saying growth or decay. From an equation, you're worried about the b value and comparing that, and then on the graphs, it's just whether it's going up or downhill. Now we're moving on to target 6 and 7, which is graphing is target 6, and then the domain and range is target 7. And I'm actually going to throw in some extra credit. We're going to talk about the horizontal asymptote as well. So first thing we do, just like we did on the front, think about what the b value is. So b would be 3, which means this is an example of growth. So I'm going to start off, I'm going to make 2 tables. The first table is just going to be with the b value. Y equals 3 to the x. This is what we call the parent function, so we're going to start there. Because this is growth, I'm going to use 0, but then I'm going to use positive numbers in the x value. If this was decay, I would use negative. So plugging those into x up here, plugging those into this x, so 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9. The second table is actually the table I'm going to graph, and it's going to deal with the transformation. So in the exponent, that's telling you what to do horizontally. We always do the opposite. So we do x plus 1, and then we do whatever this number is at the end for the y's, y plus 1. We don't switch the sign there. So for the x values, I'm adding 1 to each of the previous x values. So that means that I have 1, 2, and 3. And then for the y values, I'm adding 1 to each of those as well. So I have 2, 4, and 10. Okay, 2, 4, and 10. So then I'm going to go ahead and graph these points. So 1, 2, 2, 4, and then 3, 10. All right, and then the one more thing we're going to graph is the horizontal asymptote, which is whatever this number is at the end, which is y equals 1. And using that horizontal asymptote and those 3 points, I'm going to curve close to the asymptote and curve up through the points. Remember, asymptotes we get really close to, but we never actually cross or touch. Before we call this problem finished, we need to do 3 things: the domain, the range, and the horizontal asymptote. So the domain, it goes forever to the left and right. So we say all real numbers. The range, it goes above 1, so y is greater than 1, not equal to, because it's not going to actually touch that asymptote. And then the horizontal asymptote is y equals 1. All right, moving on to number 12. So as I'm starting this problem, if you're getting confused on anything, make sure you've watched the notes as well. That goes through all of these problems a little bit more slowly and a little bit more in detail. So this video is assuming you've already seen your notes. So this is going to be a decay problem. So I'm going to start with y equals 1/2 to the x. So when I make this parent function, I'm going to start at 0, but then I'm going to go into the negatives because this is decay. So I went into the positives on 11 because it was growth. But here I'm going to do -1, -2, and -3. So plugging in a 0 for the x up here, that would be 1. If I plug in a -1, that's 2, 4, and 8. So I'm using properties of exponents to be able to calculate that quickly. You can totally use your calculator as well. For the x values, it's the opposite of the exponent, so that would be x minus 2. And for the y values, it's the number at the end, so that would be y plus 2. So I'm going to take that previous table and I'm going to subtract 2 from each of the x's. So that'd be -2, -3, -4, -5, and add 2 to each of the y's. So that's 3, 4, 6, 10. I'm going to plot these points, -2, 3, -3, 4, -4, 6, -5, 10. And remember, you have to also graph the horizontal asymptote, which is doing whatever the y's are doing. So it says +2, so I went up 2 to graph that. And then connect your points. So these are all going downhill, getting close to that asymptote, never crossing or touching, which should make sense because going back to the beginning, we said this was decay. Domain, range, horizontal asymptote, I'm going to throw that in right here. So the domain, it goes forever to the left and right. The range, it lives above the horizontal asymptote, so y is greater than 2, and that horizontal asymptote is y equals to 2. All right, so 13 and 14 are just slightly different, and the reason they're different is they have a multiplier. So we'll talk about how that affects your tables. So first of all, we have b equals 2, which is growth. So we're going to start with y equals 2 to the x. So I actually think you guys used on number 11. No, never mind. So y equals 2 to the x, so 0, 1, 2, 3. I use positive numbers because it's growth. So 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. So 8. All right, and then the second table is the one we're going to actually graph. So the opposite of the exponent, x minus 2. And then on this problem, it's the first one we've seen on your homework that has this multiplier. That's a vertical multiplier, so it sits in front of your y value. And then we still have that +1 like we've had on other problems. So I'm going to subtract 2 from each of the x values, so -2, -1, 0, 1. And for the y values, I'm first going to multiply by 5 and then add 1. So 5 times 1 is 5, plus 1 is 6. 5 times 2 is 10, plus 1 is 11. That still fits on this graph. 5 times 4 is 20, plus 1 is 21, and then that would go off the graph. 21 goes off the graph, so I'm going to stop there. So -2, 6. And then we have -1, 11. And if you wanted to go ahead and graph 0, 21 up here, you could. The horizontal asymptote is still at 1. And then we're going to graph by getting close to the asymptote and curving upwards and hitting those points. So your domain is going to be all real numbers. Your range is everything above 1. And then your horizontal asymptote is at y equals 1. Last problem here. We have a b value of 1/3, which means this is a decay problem. So I'm going to start with y equals 1/3 to the x. Since this is decay, I'm going to do 0 and then -1, -2. So 1/3 to the 0 power is 1, to the -1st is 3, -2 is 9. And then my second table is the table I'm going to actually graph. The opposite of the exponent is x minus 1. Don't lose your multiplier there, so it's 2y minus 1. Subtracting 1 from each of the x values, -1, -2, -3. And then for the y values, I'm going to multiply by 2 first. And then I'm going to subtract 1. So then 3 times 2 is 6, minus 1 is 5. 9 times 2 is 18, minus 1 is 17. So -1, 1, -2, 5, -3, 17. And then our horizontal asymptote is down here at -1. So this graph is going downhill, which makes sense because it was decay. So last step here, domain is all real numbers. Range is everything greater than -1. And the horizontal asymptote is y equals -1. So that's your homework. Like I said, I went through it much quicker on your homework than I did on your notes. So if you have any questions, please refer to that video first.